Let me see if I can get rid of some of this noise here. Oh, all right, stop. Work. Okay. We remember ln of, oops, ln, oh, come on, pen. I hate technology. Ln of a times b is what? Ln of a plus ln of b, right? You remember this? And ln of a divided by b is ln of a minus ln of b. And ln of a to the n is n times ln of a, right? So we remember all these properties from pre-cal. If you don't remember, get them on your formula sheet. So we're going to simplify on the right here. I get the ln of 2x minus 1 squared plus the ln of x squared minus 1 squared. And now I can use that third property. Yes, I can use that third property to bring down those exponents of 2, right? So I get the ln of y equals 2 times the ln of 2x minus 1 plus 2 times the ln of x squared minus 1. And now I'm ready to take my derivative. Are we okay here? Yeah, we're okay? So I'm going to take so I'm going to do d dx of both sides, yes? So I'm doing d dx of both sides, yes? And so what do I get on the right? I get y prime over y, yes? Derivative of the inside over the inside. That easy. Equals 2 times 2 over 2x minus 1. Do you see the derivative of the inside over the inside? Plus 2 times 2x over x squared minus 1. Again, derivative of the inside over the inside. Yeah. I want to simplify a little bit here. So I get 4 over 2x minus 1 plus 4x over x squared minus 1. You can really see the problem we did already, right? You can see the factors. So, but then I want to multiply this by y. Right? You with me? I multiplied it by y. Cross multiply by y, right? So what I want to do is I want to factor out the 4 and distribute in one of each of the factors. I'm going to factor out the 4 from the right and distribute in one of my 2x minus 1s and one of my x squared minus 1s. So I'm going to factor out the 4. I'm going to leave one of the 2x minus 1s, one of the x squared minus 1s, but remember I put them back into the numerator. So I have a 2x minus 1 times an x squared minus 1 over the 2x minus 1. And I have an x, a 2x minus 1, an x squared minus 1 over my x squared minus 1. Do you see the 4 coming out to the left as a factor? And do you see the other pieces being distributed in? And that's kind of nice because then one of these goes away and these go away. And you see I have exactly what I had when I did it with just the product rule, right? Do you see it? Yeah, you see it? I don't have to finish because we know we get it, right? Nice. A couple of the problems on those old tests that I told you to cancel, like number 6 and number 6 and the ln trick, right? So the ln trick one we kind of know now. There's another ln trick in 10, I believe, but we'll look at one of the ones in number 6. Again, this is not going to be on your test, never going to be on a quiz, won't be on the final, on the chapter 3 test if you use it on one problem. In addition to solving it the way I want you to do it, I'll give you extra credit, okay? So one more ln trick problem and then we're done, okay? Oops. What the heck? Nothing's working right today. Here we go. I want to look at a problem like y equals x to the x when x is 1. And so I'm looking at that function, right? I want a tangent line, yes? I'm looking at that function and I'm going, wait, is this, how do I take the derivative? Is this a power rule? Is this a power rule? Well, when I have a power rule, right, the base is a variable and the power is a number. Is it an exponent rule? When I do an exponent rule, the base is a number and the exponent is a variable. So it's neither. This one is a brand new kind of animal. And the only way I can get the derivative is using the ln trick. So if y equals x raised to the x, we know that ln of y is ln of x to the x. And what happens on the right there? Yeah, x becomes that coefficient, right? And now if I'm doing derivatives with respect to x, on the left, I'm using my new ln trick, my ln rule, which is y prime over y, right? Derivative of the inside over the inside. And on the right, I have to do a product rule, right? You see it? So I get 1 plus ln of x. So I get y prime equals x to the x times 1 plus ln of x. And that's my derivative. What do I need for a tangent line? I need a function. I need an x. I need a y. I need a derivative. I need a slope. I need the equation of the line, right? So I know y equals x to the x. I know x is 1. I know the y value is 1 to the 1, which is 1. Yes? I know y prime, so I'm finding slope. That's f prime at 1. So that's 1 raised to the 1 times 1 plus ln of 1, which is all 1, right? Ln of 1 is 0. And I need my equation. Y minus 1 equals 1 times quantity x minus 1. So I get y equals x. Again, these problems I'm doing right now are like 6 and 6, if you looked at those. But you don't have to. It's not going to be on your test. I take things off each semester so I can add other stuff at the end, right? And I'm taking this off because you don't need it for Calc 2. My only goal is for you to be successful in Calc 2. And that's one of the things that they do. They look at faculty members. They look at faculty members' data. How does a student do the semester after they have a class with a professor, right? So, and it all depends on if it's a sequential course. Like if you're taking statistics, Math 117, anyone take that? Nice. You can tutor right away in the Learning Center. You can get a job next semester in the Learning Center tutoring statistics. I can write a recommendation letter for you if you want. So if you take statistics, there's no more course after stats. So who cares? I always passed all of my stats students because it didn't matter how they did, right? There was no other course depending upon this learning. But for you, in Calc 1, you have to know everything in Calc 1. You have to know everything from pre-cal and trig to do well in Calc 1. You have to know everything in Calc 1 to do well in Calc 2. You have to know everything from Calc 1 and Calc 2 to take any 200 level math class. But that's, I want you to be successful, right? So I'm also preparing you for any Calc 2 teacher, even the most difficult, which could be me. So on Desmos, almost done, guys, okay? Almost done. I have y equals x to the x. What's going on the left-hand side there yet? Anybody have an idea? Oh, I lost it, so it's okay. We don't deal with complex numbers in here, so that's what we're dealing with here. So y equals x to the x. I had to point, what, 1, 1? 1, comma 1. There it is. And I had the equation, the tangent line y equals x. Boom. That's why when I give you a tangent line, you graph it with the function, so you can see that you have it right. Right? Nice. Any questions for me?